Hello everyone, my name is Aristides Bampakos, but you can call me Aris because it is much shorter and it is easier to pronounce it if you are not a native Greek. And today I'm going to talk to you about how to test our Angular components with Angular CDK. The actual talk will be an introduction to a feature that is not so well known in the Angular world, which is the component harness feature of the Angular CDK. So the agenda of today's talk and what we will see is, first we will see some of the basics of unit testing Angular components. What is the proper way? What is the Angular way to do this sort of stuff? Then we will see what is component harness and why should someone use the component harness feature from the Angular CDK. And then we will see two demos, two actual use cases, how someone can use a component harness, either as the users of a library, for example, if you use Angular material, or as the consumers of or as the authors of a library, for example, how to write your own component harness and give your users an extra benefit when they unit test their components. So some things about me to get me know better. I work as a web development team lead at a company called Plexearth, and I live in Greece. Actually, particularly, I live in the second biggest island of Greece, which is called Evia Island. And I have recently moved here, and I can say all that is so great. I'm a Google developer expert for the Angular framework, and also I work as a senior Angular tech instructor at CodeHub, which is a private educational institute here in Greece, where we train other developers and professionals to the Angular framework. Recently, I became the maintainer of the Angular documentation that is translated in Greek. And for my Greek friends that may see this talk right now, you can go to angular-gr.web.app and check it out. I would love your feedback on this. And also, the last 2 years, I have written 2 books about Angular. The first one is called Learning Angular 3rd edition, and it is destined for beginners to the Angular framework. It explains all the basics that are not so obvious in the documentation or in the source code. And the second one is called Angular Projects 2nd edition, and it showcases how to combine the Angular framework with other modern web technologies. So each chapter is a different project. For example, there is a chapter using Angular with NX. There is a chapter for Angular and NGRX, and all this sort of stuff. Both my books are available either in the PactPub website or in the Amazon website. And I'm very happy that the previous month, my second book, the Angular Projects book, won 2 awards from the Bookauthority organization. It was included in the best 8 new web application development books for 2022 and in the best 100 JavaScript books of all time. If you want to connect with me with my social networks, you can reach my Google developer profile at g.dev/Aristides. So let's get started with the actual content of the talk. When we say unit testing in Angular, usually we mean that we use the Angular CLI to run the unit tests of our application, right? So we essentially run the ng test command of the Angular CLI to run our unit tests. But what exactly is happening when we use the ng test command to run our unit tests? Traditionally, the unit tests in Angular application are files that have the extension spec.ts. So the Angular CLI collects all these unit test files and passes them to a test runner, either Karma or Jest, whatever you use. The test runner will compile and run our unit tests, and it will output the result in a browser just like Google Chrome or any other browser. For example, if you are in a continuous integrated environment, you will probably use Chrome headless. Personally, my preference is to also use Chrome headless for local development because it is much faster than a regular Google Chrome. Okay, so when we say testing Angular components, what do we mean actually? I mean, what is the correct way to do this? A lot have been told and written about how should someone unit test an Angular component, right? But the proper way, the Angular way, and the way that is described in the official Angular documentation is to write our unit tests for our Angular components so that they validate the interaction of the HTML template of our component with the TypeScript class of our component. And all of this should be done in the context of the Angular framework. But how Angular succeeds, how Angular enables us to do this sort of unit testing? It contains a building class which is called Angular TestBed, and it is a utility class that allows us to interact with our component using the DOM. Actually, the TestBed class creates the component in the browser, in the DOM of the browser, just like the Angular framework does runtime when we run our Angular application. And then we can write our unit tests so that we inspect the TypeScript class, so that we can inspect how the TypeScript class and the HTML template interact with each other. So let's go and see some examples how to use the TestBed class in an Angular application. Suppose that we are the authors of a library, and this library contains an Angular component, the Hello World component. The template of the component contains a span element, and inside this span element, we have an ng content element that we use to project whatever content we want using this component. So let's imagine that the user, a consumer of our library, wants to use the Hello World component. So they use the main component, app component of their application, and on the template, they call our Hello World component, and they interpolate the value of a name property inside the app Hello World component. So if we run this Angular application, we expect to see the value of the name property rendered inside the span element of the Hello World component. So if we want to think from the unit testing point of view, the unit test that we must write should validate this exact use case. It should validate that if we set the value of the name property to something, that value will be reflected to the span element of the Hello World component, right? Let's start writing our unit tests. First, we need to set up our test suite. So initially, we add some import statements at the top of our unit test file. The first import statement imports the component fixture, which is the fixture of our component. Actually, the fixture is a wrapper over the HTML element of the actual component, and the TestBed class, which is the class that we are currently interested to use. Then we import the two components that we need so that we can write our unit test. The app component, which is the component that we want to test, and the Hello World component, because the app component uses the Hello World component. So you can think of it just like integration testing, but for components. Right. In the before each statement of our unit test, first we call the configure testing module of the TestBed class, and we pass the two components instances in the declarations property of the testing module. For those that don't know, the configure testing module actually creates an Angular module in memory that we can use for testing purposes. Then we use the create component method again of the testbed class to create our app component, actually to create the fixture of our app component. And finally, we can access the TypeScript class, the actual instance of our component, using the component instance property of the fixture. So, if we want to start writing our unit tests, by default, Angular CLI will write the first unit test that you saw here, the first it statement. It is the statement that reads it should create. And this unit test actually validates if our component can be rendered and initialized correctly into the DOM. Now, the second it statement is the unit test that we will write, right? So first, we set the value of the name property to Angular Summit. Then we call the detect changes method on the fixture that we created earlier to trigger the change detection mechanism of the Angular framework inside our testing module. After that, we can access the actual HTML element instance of our component using the native element property on the fixture. And this native element property will give us access to standard HTML methods like query selector or query selector all. In this case, we use the query selector to query our DOM for the span element. After we get a reference to the HTML span element, we can check actually if the text content property of the span element is the same as the value of the name property of the component. And so that's it. This is our first unit test that we can write. And we wrote it using the proposed testbed class of the Angular framework. That's great. Suppose now that the author of the library wants to replace the span element with the paragraph element. Okay? So they change the span element in the hello world component into a paragraph element. They release a new version. And we, as consumers of the library, download the new version and start using it. And then we run our unit tests. And what do you think it will happen? Our unit tests will fail. But why? They shouldn't, because our unit test should not care about the actual implementation of the hello world component of a third-party library. It should only care about our components inside our application. So what can the author of the library do? Of course, they can use a new feature of the Angular CDK, which is called component harness. And it is a collection of utilities that allows us to configure our unit tests so that they interact with our component using a public API. And they do not rely on the internal component implementation of the component. Let's say that it is a wrapper over the fixture element, right? So the component harness does not interact with the actual DOM. It interacts with a wrapper over the fixture. If you see from the code that I will show you later, this pattern, the component harness pattern, is heavily inspired from the page object pattern that you see in integration testing. And what are the four main ingredients of a component harness? There are four. First, we need the npm package, and this is the Angular CDK testing npm package that contains all this infrastructure and artifacts that we can use to interact with component harness. Then we need an environment for our tests. The Angular CDK contains two built-in testing environments out of the box. One for unit testing with Karma and another for end-to-end testing with Protractor. I would like to note here that a a component harness can run without any change, either in unit testing or in end-to-end testing. So you can use component harness approach also in end-to-end testing. Then the third ingredient is a harness loader, which is a class that is used to create and load a component harness inside our unit tests. And finally, we need the actual component harness implementation that gives us access to the instance of our component inside the DOM, but without querying the DOM actually. That's cool. Let's see some use cases. How could someone use the component harness? First, we will see it from the point of view of the user of a library. For example, we will see how to use component harness if we have an Angular component that contains an Angular material component. Let's see. Suppose that in our application we have a button component, and in the template we have a standard HTML button element, and this button element is styled as an Angular material button component, as you can see from the mat button directive. And on the text of this button element, we interpolate the value of a title property of the component. So whatever the value of the title property is, it will be reflected on the text of the button. And this is what will be the first unit test that we would like to write. Now, attention for this one. We can write our unit tests by querying the actual HTML button element and using standard query selector methods, right? Standard HTML methods. And with this approach, we would not care about the mat button element. But for the sake of this demo and to showcase the power of component harness, we will try to write our unit test by querying the Angular material button component and not the native element. So the setup of our test suite is a lot bigger, as you can see. Generally, when you write component harnesses, there is a lot of boilerplate involved. So first, we have two import statements that are the same as we had before. And then we have three more import statements. The first one imports the harness loader that we need to create our component harness. The second one is the testing environment for unit testing, which is called testbed harness environment. And the third one it's a bit weird because it says mat button harness. So what actually is this mat button harness? Bear with me for a moment. Every Angular material component has a respective component harness class. So an Angular material button has a mat button harness class. If you use an Angular material menu component, it will have a mat menu harness class. And these classes are used so that we can query the Angular material components using these classes and not the actual DOM. Okay? So in the before each statement, after we configure our testing module and we create our component, we call the loader method on the testbed harness environment to create our actual loader class. To create our actual harness loader. And in the loader method, you will see that we pass the fixture as a parameter. So we can conclude from this line that a harness loader is connected to a specific component fixture. And that is why I said before that you can imagine about component harness as a wrapper over the fixture. So in our minds, we can imagine it like this. On the bottom, we have the DOM. Above the DOM, we have the fixture. And above the fixture, we have the component harness. So how we would write our first unit test that validates if the text of the button correctly reflects the value of the component property. First, we set the value of the title property to hello Angular material. Then we use the getHarness method on the loader that we created earlier, and we pass the specific component harness instance that we are interested in. In this case, we are interested to query Angular material buttons, so we pass the mat button harness as a parameter. Finally, we use the getText method from the mat button harness to validate if it is the same with the value of the title property. Two things that we should notice here. First, we use the async await syntax. Why? Because component harnesses are promise-based. Second, we don't need to call the detect changes method of the fixture. Why? Because the change detection mechanism is automatically triggered by the component harness. So by using component harness, our code is more readable and it is much less. Okay, suppose now that we had two Angular material buttons inside our template, and we would like to unit test only one of them. What can we do in this case? We can use a predicate function inside our getHarness method. A predicate function is a with static method, as you can see from the mat button harness.with statement, that accepts the text of the Angular material button that we are interested as a parameter. So in this unit test, we will target only the Angular material button that contains the phrase click me in their text. Right, so we show how to use component harness as the users of a library, and particularly Angular material. Let's see what we can do as the authors of the library. So we will go back to our initial problem, where we would like to replace the span element with a paragraph element. As the authors of the library, we will try to create our own component harness, like the Angular material library does for the mat button harness. We will do the same for the hello world component. So a component harness implementation is nothing more than a TypeScript class that extends from the component harness base class, and it contains at least a host selector static property that identifies the underlying component and is usually matched with the selector of the component. So in this case, the value of the host selector property is the value of the selector of our component app hello world. In this case, we also use the locator form method to locate the span element from the template of the hello world component. The locator form method actually returns an object of type test element and contains some methods that we can use to interact with the underlying DOM of the component. For example, click, focus, and text, as you can see in this example. Here we have created a getText method, a wrapper method, just like the Angular material button does, and we locate the span element, as you can see from the getContainer element call, and then we return the text of this span element. Now these three lines are the same as we did before, where we wrote fixture.nativeElement.querySelector span. It's the same, but in this case, we don't touch the DOM. So how can we use this component harness? Sorry, when we, as authors of a library, write our component harness, we make a new release of our library and publish it to NPM or some other package registry, right? So how can someone use our component harness? This unit test is the same as the one that I showed you before in the beginning, but I have trimmed the setup of the whole test suite for clarity. So here we are actually calling the getHarness method of the loader that we have created, and we pass the custom hello world harness of the library this time. And then we can use the getText method and validate if it is the same as the value of the name property. Now, let's say that the author of the library finally decides to replace the span element with a paragraph element. What should they do? They should go to their component harness and change the locator for method so that it accepts a paragraph element. Of course, they will change it also in the template of the hello world component, right? So they change the locator for method, they release a new version of the library, and they publish it to the package registry. And we, as users of this library, we download the new version, we install it, we run the tests, and guess what? The tests will stop to fail. Why? Because we are not interested either if it is a span element, a paragraph element, or any other element. Our unit test is concerned only with the component harness of the library and not with the underlying DOM. So, to recap, I would suggest you to go and write your unit tests with Angular CDK. It is an amazing feature of the Angular CDK. It is reliable because it is maintained by the Angular components team, and it makes your unit tests more readable and scalable. So today we saw how to test an Angular component in the Angular way. What is a proper way to do it? What is a component harness and why should someone use it? And then we saw two use cases. One, from the perspective of the user of a library with Angular material, and another one as the authors of a library. In this slide, I have put some very useful links about testing general and component harness. The first link is a StackBlitz demo where it contains all the code examples that I show you today and plus more. For example, it contains an implementation of a custom predicate function for the component harness, for the hello world component harness. And the other three are the testing components guide from the Angular docs and the component harness guide from the Angular material docs. Thank you so much for the attention. I hope I inspired you to go and check out Angular CDK. And I hope you will have a very great summit. And any question you may have, I will answer it in the Q&A section later. Thank you very much.